This is a video for AQA Further Pure Mathematics. This is Hyperbolic Functions, section 1.1, where we're introducing the idea of hyperbolic functions, their definitions and graphs. Well, first I want to explain to you why the new functions are called hyperbolic functions. You've already met sine and cosine as functions, and these are properly known as the circular functions because we can use them to produce a curve which is a circle by describing the coordinates on the circle by the values x is cosine t and y is sine t. So a point here is then given by what are called the parameters cosine t and sine t, and as t changes the point moves round the circle. Now the reason for that is because we know that cosine squared t plus sine squared t is equal to 1. So wherever we are, whatever value t is, then the radius is going to be equal to 1, and hence the circle is as shown. The new functions that we're going to look at in the next few slides, if they're used as parameters, they produce a hyperbola, and hence they're called the hyperbolic functions. They're actually given the names Cosh and Shine. So the first of these then is the function Cosh X, defined in terms of exponentials. So Cosh X is defined as being a half e to the x plus e to the minus x. So if we look at a graph of that, well, y equals e to the x, we know looks like that, and e to the minus x is just going to be a reflection of that in the y-axis, so there's e to the minus x. If we add those two things together and then divide by 2, well, certainly the graph is going to go through 1, because 1 plus 1 divided by 2 is 1, and it's going to increase as x increases towards infinity, either positive or negative. So we can see that Cosh X then is this curve in green. Now in fact, as Cosh X approaches a half e to the x as x approaches infinity, that's because e to the minus x is going to be equal to or approaching 0, and likewise as we go to minus infinity, then e to the x is going to approach 0, so that Cosh X approaches a half of e to the minus x. So Cosh X is a half e to the x plus e to the minus x. The second function is normally pronounced shine. Some will call it sinh, or even just sine h of x. So there are a variety of different ways of pronouncing this, and you can take your pick. Shine x is defined as a half e to the x minus e to the minus x. So this time we're going to be subtracting the functions, and we'll see what happens. Therefore, if we go look at, first of all, an x equal to 0, we're going to have 1 minus 1, so it's going to go through the origin. And we can now think about what happens as x gets larger. Well, as x gets larger, we can see that e to the minus x is going to become smaller and smaller, so it's going to approach a half e to the x. And as we go the other direction, we're subtracting the red curve this time, and as e to the x is going to get smaller and smaller, then we're going to the negative part of the graph. So I've already said it approaches a half e to the x as x approaches infinity, or negative a half e to the minus x as x approaches negative infinity. Well, we can look a little bit more closely at the properties of these two functions then. So firstly, let's look at sin x. We see sin x there in the yellow. This has got rotational symmetry about the origin, and therefore we can say that sin x must be an odd function. Now we can actually prove that it's an odd function by looking at sin of minus x, and we can see therefore that basically it becomes negative of sin x. Now the idea that f of x, or f of minus x rather, is equal to negative of f of x is what we mean by an odd function. So that's our definition of an odd function. Cosh x, on the other hand, we can see has got reflective symmetry in the y-axis, and this is the signature of an even function. But to prove it's an even function, again we'd need to look at cosh of negative x. But we can see that cosh of negative x, because we've got plus in there, it must be equal to cosh x. And so we've shown that f of minus x is equal to f of x. And that's our proof of an even function. So sin x is an odd function, has the rotational symmetry, and cosh x is an even function with reflective symmetry. And finally, if we add the two functions together, so if we take sin x plus cosh x, we can see that we'll get a half e to the x plus a half e to the x. And therefore, we can say that sin x plus cosh x is equal to e to the x. In the same way as with circular functions, we can take sine divided by cosine to give us tangent. We can do this with the hyperbolic functions, and we produce a new function which is pronounced in several different ways again. So tanch is one way of doing it, or than, tanch x, or than x, or tan h, hyperbolic tangent. So tanch x is sin x divided by cosh x. And of course, if we use our exponential functions there, the halves cancel out, so sin is e to the x minus e to the minus x over 2, and cosh is e to the x plus e to the minus x over 2. So the 2's cancel out, and we get the following. So tanch x is e to the x minus e to the minus x divided by e to the x plus e to the minus x. This can be rearranged in several different ways, but one way is to divide through the top line by e to the x, so that we get 1 minus e to the minus 2x, and do the same thing on the bottom line, so we get 1 plus e to the minus 2x. So dividing through the top and the bottom line by the same thing, e to the x, gives the following, and that's one alternative version of tanch x. Well, looking at this rearrangement, we can see that if e to the x approaches infinity, then e to the minus 2x approaches 0, and so therefore, as we go towards plus infinity, x gets larger, then tanch approaches 1, and if we go in the other direction, then it will approach negative 1. And the reason for that being that the 1 becomes irrelevant, so that we have minus e to the 2x over e to the 2x. Which is equal to minus 1. Well, that helps us to think about the graph of tanch x. So cosh x and sin x, if we divide them, we can see actually that sin x approaches cosh x as x goes off to infinity, and therefore we get the 1 there. And sin x approaches negative cosh x as you go to negative infinity. So putting in those vertical asymptotes at 1 and negative 1 gives us the following curve for tanh. That's the end of this particular video on looking at the definitions of hyperbolic functions, and the next one we'll look at solving some simple equations using those definitions.